It's probably the third one of these live streams now or something like that. I think it's Thursday. I sort of don't really know what day it is half the time at the minute, but never mind. So it's early-ish in the morning UK time. It's 9:30, which means we have some good light here. And I actually watched yesterday's stream back and realized that half the time when I was looking at the other camera or something over on the mat, or we were building the breadboard Pico that we did yesterday, the microphone wasn't really following me very well. And this is a new desk setup, so I'm kind of still dialing that in. So I've made some changes today, and we'll see how that goes. Somebody also pointed out that the second camera, so this guy, so let's put something on that, could be a little bit shaky or what have you, because I always have to hold things up close to it. So what we've got is, let's see if we can demonstrate this. This camera is a Logitech thing, and it comes with an application that allows us to mess around with some of the settings. That it's a bit of, unfortunately, you have to do it in a separate application, but let's see. So that's reasonably in focus right now. But with this, I can, here we go, change the zoom and so forth. So the ultimate aim for this second camera is for it to be on an arm overhead or something. But the arm needs to be fairly stable, because if I put my elbows down on the desk, it's going to shake the desk, and then it would shake the camera, and you would all get seasick. So I don't know. We'll see. We'll mess around with this. These streams are partly intended as a sort of shakedown for me, because I haven't done this in a while, and for a reasonably new environment. Everything behind me looks the same to what you've been familiar with if you've been watching my streams before, but some of the stuff all of the stuff on the desk has changed. Which computer I use, how the monitors are set up, all the power routing, where the lights are, and all of that stuff has all changed. Also, this morning I've got coffee, as probably this is going to be a usual thing. I will have coffee. I've been collecting these San Diego place mugs. So this is San Diego. I've been collecting these Starbucks place mugs. This one's San Diego, which is somewhere I used to live. And what you'll see is, over the course of a series of streams, the place name changes, as we have a small collection of like 7 or 8 of these mugs, and they're mostly from different places. So you can spot the place name on the mug. So what we here to do today? Well, the stated aim of these streams is to do the PiHut Maker Advent Calendar, and yesterday we did box 1, which turned out to contain a breadboard and a Pico H with the headers attached to it, and a USB cable. And we plugged all of that in, and we installed MicroPython, and we ran some code, and we got the sort of IoT Hello World LED blinky thing going. So today, at some point on the stream, we're going to attempt the box 2, and I'm doing this blind, so I don't know what's in the box. I have no foreknowledge of this. We shall make it up as we go along. However, before we do that, I had a couple of other things I was going to do. So let's move some things around so we can share a desktop here. Here we go. Hey, let's bring the desktop in. Here we go. So here's the Maker Advent Calendar. This is what we're here to do, and we'll come back to where the instructions are for that. But the other thing I was doing on this stream, for variation, is just sort of generally talking about other stuff I've been working on. So I've been showing on my Twitter, and you can follow us on Twitter. I'm still going to call it Twitter, and I'm still going to say that most days. You can follow us on Twitter and see what's what. But one of the projects I've been working on there is the e-ink ISS tracker with a little Pomeranian badger. And that's not on my desk today. The reason it's not on my desk today is because it is being packed up, and it is going to the post office this afternoon, or one instance of it is going to the post office this afternoon. It's going to get sent to a relative for their Christmas gift. And I have a couple more to build. But what I did was I sat and wrote a manual last night for this. So I want this thing to be sort of a product. So you would receive it with the software installed, and you'll plug it in, and it exposes Wi-Fi access point, and then from there you get a little web page and you can configure it. So I wrote a manual with some help from my partner, and you've got some stuff in here for how to assemble it. So you put the legs on there. Primarily don't currently sell the legs separately. These are actually from another Primarily product, one of the unicorn class displays. I think I showed it the other day, but here it is. So this is a cosmic unicorn. It's a LED matrix. We'll play with this in future, and it comes with legs, so it can stand on your table, and you can sort of glance over at it. And I found that those legs fit the e-ink screen quite nicely, so we did that. So I basically created some assembly stages, and then how it tracks the ISS and all of that, and how to reset it. So I made a simple process. You press A and C, and resetting it wipes its stored Wi-Fi credentials and its stored location. So it needs the location to work out how far the ISS is from wherever you are. So what I just wanted to show here, and we'll look at this probably on the stream at some point, is the setup process here, because there's Primarily especially make a few of these products where there's like a Pico built in and some sort of display. So, you know, this is one of them, this unicorn. There's your Pico in the back. And I kind of love the idea of upcycling these into a product that does something. So the fact that there's a general purpose computer in there isn't relevant to the end user, but, you know, I would put some software on there, so like the ISS tracker. But I would want it so that the user gets something that looks like a product. So like when you buy a new smart plug, or when you buy a new Amazon Echo device or whatever, there's like a nice headless setup process that you can go through. So I built this thing that allows, you turn this thing on and it says, oh, I've not got a stored Wi-Fi configuration. I'll pop up an access point. You connect to that access point on your phone. It works fine on a Mac as well. It just works like connecting to cafe Wi-Fi. And then what pops up is the phone thinks it's a login screen, because it thinks you're on one of those Wi-Fi networks that wants your email address or has a login step or wants you to agree to terms and conditions. But this is actually a small web server that uses another Primarily framework, software framework, running on their device, and it exposes a little web form that I went as far as styling a little bit, but not very much, because this is a captive portal, right? So you have there's no internet access at this point. So I can't like reference some sort of front end framework or whatever on a CDN and download it. I'd have to download it all to the little Pico and serve it from the little Pico. So I did some absolute minimal styling with I think it's called Pure, the framework I used. Not even really a framework, it's just like a sort of CSS reset and some basic styles. But I put that in there because it saved me having to come up with some rules myself. And that means that the form here for the SSID and the password and putting in your location, latitude, longitude, and the save settings buttons, they're all reasonably nicely styled. They're not crappy. So that's all okay. There's what else is going on here? Let's see. I would have loved to have, instead of punching in a latitude, longitude, which is not that like end user friendly. If you're not a tech person, you don't know to go to Google Maps necessarily and get that. I would have loved here to have had a button that uses the browser location API to sort of self-locate and populate this form based on where you are. But that, at least in Chrome, and I don't know much about the other browsers, but I'm going to guess that it's a problem generally, or it will be a problem on Android if it's a problem in Chrome. Those things, those APIs are reserved for, I think it's localhost or SSL pages only. So I then have to deal with SSL on the web server on the Pico in MicroPython and shipping a certificate, and whether the phone would trust it or not. So I just didn't bother. I just did latitude and longitude and save settings. And then once you save the settings, it creates a Wi-Fi credentials file on the Pico, reboots it. The code goes down a different path, knows it's got the Wi-Fi, and then you get this hole I'm connected, and there we go. It was over the North Pacific at the point at which we a point at which we captured this. So yeah, that's something that I did yesterday. The other thing that I did was I said, and I think I showed this box yesterday. Not very. It's a nice box. It just doesn't have a picture of the product on it. I got hold of one of these smart plugs, and the smart plug that I got runs Tasmotor, which I don't know very much about, but I understand it to be a sort of more open system for smart devices than, say, one of these things that kind of only connects to their cloud service. So I wanted a smart plug that didn't use a cloud service so that I could turn things on and off directly from another one of my projects. So if you remember this thing, which is another one of those Pomerani products that has that Pico on the back, and I'll turn it on and we'll put it in view of the other camera and see what happens. But if you remember that thing, what I've got it doing is tracking the electricity. Let's have that camera. There we go. Not great in that view. So let's just swap that to bigger view. Okay, so this is quite bright. And I wonder if we can mess around with our little Logitech app. But what I've got it doing here is, let's see, zoom out a little bit perhaps. And it's gone out of focus. Yeah. The more you play with this stuff, the more you think actually using like a digital SLR as the second camera is best. But anyway, you get the idea. There's we're having a bad day for electricity, carbon intensity, which seems to be the case most days where we live. My electricity at the minute is mostly actually coming from generation that's powered by natural gas. So the screen is red, and it could be green or orange or yellow or whatever. It's updating right now. Depending on what the power mix is at a given time. So you would hope at some point during the day that we're sort of saved by wind, and others includes things like biomass, and things get greener. So what I wanted to do was have this control something that it could turn on or off that maybe consumes a lot of power. So let's put that back in its place. There we go. And the easy way of doing that, I mean, I could build something with a relay and control it directly off the back of that unit, because that unit has got an expansion sensor port. It's a demo QT, pretty standard thing. Could have done that, but I thought the lazy and easy way of doing it, because you probably don't want the display near where the thing you're controlling is just to get a smart plug that has like an open API. So I got one of these plugs. It's a Tasmotor plug. And what that means is it runs this thing. So open source firmware for ESP devices. There's some sort of little ESP inside the plug. And we'll just get rid of the second camera because we're not talking about that. So it runs that, and it seems to have a few APIs. So here it says like control using MQTT, which is great. Web UI, which is great as well. HTTP, which is good for me. I can make HTTP requests from this little device. So I'm going to spend a little bit of time looking at, can I have the tiny power intensity device turn on a plug when times are good and turn it off when times are bad, and maybe make it so that the power intensity device doesn't draw power when things are bad. So, plug the plug into a battery bank, plug the battery bank into the power intensity device, and then have the device control whether that plug is turned on, charging the battery bank, or turned off. So we got the device, it's plugged in, and let's just see if we swap to a second camera. No, it's not going to work like that. Let's come back. And let's add the desktop back. There we go. So I've got that set up on the desk, and there's a lamp to my left. Let's see. See that? There's a lamp there, and the plug is somewhere down behind me. So what we can try and do is turn on the plug and see how that goes. So let's see what we can do here. So I set up the plug. It was really, really easy, and it works by a couple of ways. So it's got an IP address, and if we bring up Postman here, we can see that is the IP address. And I read some Tasmota documentation, and what's nice about this is it's a standard, so things will sort themselves out according to a standard, so I can make calls to this, and I don't need to know like whose Tasmota or whose hardware it is. I'm going to clean this camera because it's annoying me that I went and touched it and now it's gone out of focus. You gotta come back in. Maybe. Let's try that Wonderbar Logitech app because that also controls this camera. So that's better, isn't it? What I found with StreamYard as well, just sort of general, not rant because StreamYard is great, is sometimes the camera drops out of focus, and then when you bring the Logitech application up, so I've got this thing like, here we go. Just bringing this application to the front and selecting this camera from the like devices it can look at, ping the camera back into focus, and that fixes StreamYard. So I don't know, weird. Anyways, so yeah, the plug, I got it on my Wi-Fi. The setup process is remarkably similar to the one for that ISS tracker. You know, it exposes a Tasmota dash device ID access point. You set it up with your real Wi-Fi. And then once you've got your real Wi-Fi, it gets an IP address and it tells you what that is. Or you can scan for it on your router. So mine is this 1242. And if we go to there, what you'll see is it's got a little web interface. So I can, through the web interface, toggle the power, and you can see I get a bit brighter and darker. The light that I've got on the desk is coming on and off. Angle it towards me. There you go. Bright, dark. So we can remote control the plug. So that's great. And then I looked at how this works, and you can turn security on. I don't kind of need that for what I want to do. So basically, you go to the HTTP interface and you just do GET requests and you send it commands. So let's send it a state command, and you'll see the response to that command is a JSON document. And in here, it says that the power is off. We've got some stuff about the Wi-Fi connection that it is configured with. I'm not sure if this load average is something to do with the power usage across it. I don't know. But I also found there's a different command called, I think it's status, that gives us slightly different stuff. So that gives us power as 0 or 1 now rather than on or off. And it tells us about LEDs and all sorts. I guess this is a sort of general for this class of device response. So I don't know if this plug's going to have all of these features. But what we can do is do, not a fan of this because it requires a space in the URL, but the command power on like this. And you can see I got a bit brighter and there was a quite satisfying relay clip behind me. The plug's now on. And then if I do power off like that, and then we get a response that tells us what the current state is. Let's turn it back on again. And now let's do state, and you can see the power is on. And I guess we could leave it on for a while and see if this load average changes, or we could just read the documentation. But anyway, this plug's going to work great for what I wanted because I can change my MicroPython for the little device here and have it so that when it transitions between like a heavy carbon intensity state and a low one, it turns the switch on or off and changes its ability to charge the battery bank that's powering it. So it's a silly little example because this thing draws basically hardly anything off of our electricity, but I could be, working out when to turn on or off the car charger or something like that. Should we all do this? I don't know. If we all started charging things when the carbon intensity was low, you could argue that will blow through the low intensity generation sources pretty quickly, and then it will go back to red anyway because they'll fire up the gas and the coal. But I don't know. It's an interesting thing to mess around with, and very simple. And obviously, we could control anything with this plug that we could leave turned on. I could go to bed with the coffee machines all set up for tomorrow with the water in it and all of that stuff, and just press the button and come down, and there would be coffee at an appropriate point. We can build a make me coffee button. Unfortunately, we can't build a refill the machine with new supplies, but that's what it is. So yeah, we've got that. Let's turn this off now because the percentage, the space thing still makes me laugh. But there we go. Oops. Whoops. Command. Oh, is it something like command equals power off? Something like that. Yeah, there we go. And the power's off. So that's the Tas motor plug, and that may feature in things in the future. So that's it. You can get it from AliExpress. I mean, there's probably loads of these because it's a standard. And that was what we were doing with that. So one final thing that I did yesterday was over on my website, I have a page of books that I've read. It says here, I don't offer opinions on these. I just pick a book from the library and read it. So basically what you can guarantee is if there's a book on this page, I have read it cover to cover. And I'm pretty busy with this at the minute because I've got a fair amount of time on my hands. So we've got, the last time I updated this was December the 9th, but I finished a book yesterday and I need to update the website to include that. And what I wanted to do was just quickly, again, because this is all sorts of things stream, and we will get to the Maker Advent Calendar. What I wanted to do was quickly update my website with this new book that I've read. So my website's a GitHub Pages site. So if you go over to my GitHub and you go into repositories here, you'll see one called simonprickett.github.io. That's how GitHub Pages, where I host it, works. And in here is a Jekyll static site generator website. So it's mostly Markdown. It's some HTML with a load of templates. And there's a build process that you run that generates a static website. And then what I do is every time something gets pushed to master, and I should change that to main, there's just automation that needs updating. Every time something gets pushed to this primary branch, GitHub Pages runs an action automatically, builds the website and publishes it. I then have Cloudflare in front of that for other reasons, but basically it's a GitHub Pages site. So what we're going to do is take a look at updating that really quickly in real time because it's something that I need to do. So I've got the site cloned locally, and here in VS Code, we can go to, I keep stuff that isn't like an article. So the majority of the website, back to here really quick, is what I call articles, what Jekyll would call a blog. I just don't use the date and time on them because it's not really a blog. I write articles about projects. So each one of these, let's pick this one, is a markdown file, and then it gets rendered out. And then each one of these things across the top, so the about me and how to get hold of me and all of that stuff. These are what Jekyll calls pages because they're like one-off things that live at a fixed URL that isn't determined by the file name and so on. So I've got a folder here for all of my pages, and the reading list page looks like this. It's a mix of, you can put HTML in Markdown. I just did some layout for this. So I did, rather than make a reading list template and then have like a Markdown list, which may be a better way of doing it, or a YAML list or something that, it combines the template and data to build the page. I just put in an HTML. It's basically an ordered list with some styling. So what we're going to do is update this a little bit. And what I need to do is check where we are. That's a bit bigger. Ooh, that's a win. Oh, there we go. That's better. And let's do new book, December 14. So we've created a new branch for that. I'll try and do everything on branches, even though I'm me working on this site. It's just kind of good practice. And also because I start things that I don't finish, so I can keep them on branches and then finish them later. So there we go, December the 14th. And then what I generally do is, it's a rolling list of 10. So I just get rid of the last one and paste it up here. And then we need to find the author. We need to find the link, and I use Goodreads for that. And then we need a title. And I need to quickly grab my phone. I don't even remember what book it was that I read. I can remember about the book, but I can't remember the title. But luckily, I've got a handy get it done list on my phone. So it was called I Will Greet the Sun Again. So let's find that really quick. So let's go over to Goodreads here. And Goodreads is funny because they hide the search box like right down here. So, I Will Greet the Sun Again. Let's see what it's got. So yeah, I don't care about that. Oh, there's two of them. So it was actually this one that I've just read. I get all of these books from the library on the library's e-reader app. So big fan of the library. So here we go. We need a title. I Will Greet the Sun Again. We need an author. Here's our author. And author goes there. And then we need a link minus the search parameters because we don't care about those. So put that in there. All right, so I've saved that. So we've now got, we should have like one file that's changed. One thing that bugs me about GitHub Pages is I can't preview this branch. I can't push this branch and then preview it remotely and share it with other people, like if you're familiar with Netlify or other things. I might actually move this site to Cloudflare Pages partly to get that. So you can have it auto build and deploy branches. You can restrict who can see them and all of that. I played around with it with another website project recently. I was quite impressed with it. So I might do that while I've got a bit of downtime. But for now, what I'm going to do is need to start the Docker engine. Jekyll's Ruby. I'm not a big fan of Ruby, and I find the dependency system, frankly, difficult to manage. So what I've done is there's a simple Docker compose file here that just runs all of the Jekyll nonsense in a container, so I don't have to worry about it. So if we do Docker compose up, what we'll see is it goes ahead and it should build my site. And here it is, Jekyll's generating it. It's going to take probably about a minute to do that because there's quite a lot of articles in the site. And once it's done, it'll show the site on localhost 4000 and we can check that our book change is okay. And then once that's happened, we can push the branch and do a pull request and merge it, and then GitHub will take over and put it live for us. So while that's cooking, we can go ahead and let's pull box 2 out of the Advent calendar here. So let's just temporarily swap back here. Got the Advent calendar. I do love that this is so well packaged. So I pulled box 2 out. There are, remember, instructions for how to do this and what to expect in the box. So we are going to mess around with that in a minute. Still waiting for this site to generate. Oh, it's done. Okay, so we can bring the desktop back. Let's do this. Not like that. Okay. So as you can see, it's now running the site on localhost 4000. So let's go to localhost 4000 and it will take its merry time in a container and serve the site. There it is. And our reading list should now hopefully have, there we go, it's got the new book at the top, updated on the 14th. And if we click that, it should go back to Goodreads. Okay, so there's a job done on the stream. So all that remains now is to let's see, git commit. So okay, let's push that. And then over here, I love how things just pop up on GitHub when they happen. You don't have to like refresh the page or go away and come back. So we're going to do a compare and pull request on that. Let's just, I am a big fan of doing that. So let's set a label and so forth. And let's create a pull request. Even though it's just me, I'm the only person that works on this. And the only file that's changed, just verify that, is our books changed. So yeah, that looks fine to me. So what happens when I merge that one and tidy up and delete the branch should be that over here in actions, yeah, what you'll see is GitHub has queued a couple of things. So it's doing pages building deployment. The other one is a GitHub action that I'm working on that will eventually change my profile level README whenever I publish a new article, just automatically. That's not operational at the minute. So what happens is it's doing the Jekyll build in the cloud now somewhere on GitHub, and then it's going to get the static artifacts and load them to GitHub pages, web hosting. And when it's done that, what we should see is the live site here, my URL. And let's change that, or let's put that up. So the live site here should then contain the new book. And that's basically how I look after my website. Is it the best way of doing it? I don't know. Is it completely free and has things like SSL and hosting that I don't ever have to worry about? Yes. So that works well for me. So it's still building this, and then when it's done it, it'll report the build status and so on. So let's flick around a little bit and set this up. So we're going to do day 2 of the Advent calendar. So down here somewhere, there was maybe I'll scroll past it already. There we go, daily online box guide. That's what we want. We've got this red one as opposed to the other one that focuses more on LEDs. So we've got day 2. So let's see. So yesterday we did some blinking of the internal LED that was built into the board, and today it looks like we're going to do something else with LEDs. Let's just flick back to, no, we're still building over here. So we'll carry on. So let's see what this says. Welcome to day 2 of your 12 projects of Codemaths. I need to do some maths and figure out when I'm going to finish this, assuming I do it Monday to Friday until we're done. But that's for another day to worry about. So LEDs are a staple component for makers of all experience levels, come in all sorts of shapes, sizes, and ratings, and are everywhere. Okay. So in this box, you will find 3 LEDs. So we've got red, amber, and green. So that kind of looks like traffic lights, which is a project that I did a lot of on my website back in the day. So yeah, ever wanted to see how to get started with LEDs in a regular Raspberry Pi, then I wrote articles in all sorts of languages that you wouldn't necessarily expect on how to control traffic light LEDs. So here's Swift, for example. You wouldn't think you can do IoT coding on a Raspberry Pi in Swift, but you can. So I used these things that plug into the Raspberry Pi and were sort of pre-built traffic light, and they just attached to 3 of those GPIO pins and a ground wall. So if you're interested in that, there's lots of articles like that on the website. But meantime, back to here. So we've got some resistors and we've got some jumper wires. Oh, there's a nice picture of everything that should be in the box. So let's open the box and see what's going on. So I've got the box open and camera 2. Let's move to a big view of what's over here and put that carbon intensity display away. We're not going to play with that anymore today. And here's the box. And in the box seems to be what they said will be in the box. So that's good. So let's get that out. It's all nicely in a single bag. I am making sure to put things back in the right box when we're finished with them as well. So hopefully maybe someone else can have some fun with this in the future. We'll see. So we've got one, two, 3 LEDs. Some resistors. And as they promised, some you know what? It would be a good improvement to like put a line of tape around this board or something so that you can see where the focus area of the camera is. I mean, I can of course move it. It's not a big deal. But we've got that stuff today. So we can see what we're going to do with that. But let us just really quickly nip back over to here to our GitHub pages. So it's gone green. It's gone green. It built and deployed everything. So if we go to here and do a refresh, there we go. Our new book, I Will Greet the Sun Again, is on the list, on the live site, and last update on the 14th. So that's good. We can forget about that now because we've done that. We can turn Docker off and save some machine power. And we can get rid of VS Code because that's not where we're doing our MicroPython project. So, okay, back to this. Maker Advent Calendar Day 2. Looks like it's going to be LEDs. So, let's see. What is an LED? It emits light when electrical current flows through it. Okay. So they have 2 legs, one longer than the other. So can we see this smoothly here? That's not very good, is it? Let's make camera 2 a bit bigger again. So we've got LEDs. Yeah, you can see there, look, one leg is a little bit longer than the other, not much. So they were telling us why that is the case. So let's see. They have a specific, that's hard to say. They have a specific polarity. So electrical current can only flow in one direction. And if not, we can damage the LEDs. So we've got to be careful here. The long leg is the anode, which basically means positive. And the short leg is the cathode, the negative. So current must always flow from positive to negative. So we have to follow the wiring instructions carefully. Otherwise, we're going to blow up an LED. And I guess release the magic smoke or whatever. So they usually require a current limiting resistor when using them with a microcontroller. That's because these microcontrollers generally, the way that they control the pins is it's going to be you get no current coming out or all of the current, and it's usually like 3.3 volts or something. So if your LED needs less than that and you send that much through it, you're going to blow it up. So the resistor kind of burns off some of that, if you like. So it doesn't matter which side of the LED the resistor sits, as long as it's there. So, okay. And here's a map of the Pico's pins. And okay. The numbers in the grey squares are the physical pin numbers, so they just go around the board. And then these things here, the boxes off to the side, are essentially what we know them as in MicroPython. So physical pin 2 here is going to be GPIO 1. So having a copy of this sort of thing around is really handy when you work with these. And there's a link to a PDF version as well. So let's have a look at that. There we go. So we can make that nice and big. So there's a nice big diagram of the Pico. And as you can see, some of these pins do other things. So you can turn them on or off, and they also serve other purposes, but that's kind of beyond the scope of what we're doing today. So we won't worry about that. So what have we got? Construct the circuit. So first, make sure your Pico is disconnected from the USB cable. Well, there it is. There's no USB cable. Then grab the set of jumper wires. Excuse me. Right, sneezing fit. That's the first. Then grab the set of jumper wires, resistors, and LEDs. So, okay, I've got wires here. They're kind of stuck together, so I'm going to peel them apart in case we need to spread them out. Hopefully, this won't prove to be a mistake, but I mean, they come sort of glued together like a ribbon, and you can just pull them apart. I'm going to pull them apart here for a moment. Yeah, there we go. Right. Okay, we're going to be adding components to our breadboard. So the breadboard is the thing here that we can plug stuff into, and they have horizontal channels. All the red pins are connected, as are the blue, but each side is disconnected from the other. So we use these to create rails of connections to use. So basically, you can create one line across the board. And the holes in the middle are connected in vertical lanes, with each having 5 connected pins each side of the divider. Yep. And as you'll see, our Pico is sort of straddling what's called the divider down the middle here. So it's on both sides of this board. So place the 3 LEDs in the lower section of the breadboard, one hole apart, with the longest LED to the right. You won't know which. I was wondering about this. So you see here, there's like red, yellow, and green, which is great. But what we got in the little box is clear, clear, and clear. So okay, so they're going to help us with that. You won't know which color is which yet. So okay, we'll just play along with this, but that doesn't matter, and we'll come back to it in a moment. Your breadboard should look like this. So the longest LED to the right. So here's the. Let's see if we can do something a bit better. Right. So here we go. So here's the breadboard. The debug probe on the end of the Pico is there. That's what they want. And then it says I should have the longest leg to the right, and it should be in there. Okay. I should have the longest to the right, and it should be like here in this area. Okay, so there's one. So I don't know if you heard that, but that attached fairly firmly. And then I need 2 longest to the right. So let's line them up. That one's attached as well. These are quite long legs. They stand up, quite proud of the breadboard here. And then 3. Okay, so let's pull it out of the way of me. There's 3 LEDs attached to that. So now it says, just come back to here so we can see what we're doing. So we hope you've done this step. Now it says we need to add a resistor to limit the current that the LED can draw from our GPIO pins, right? So we don't blow it up and release the smoke. Place a resistor between the left leg. Is that better? Okay. Place a resistor between the left leg of each LED and the lower blue channel. So like this. So you see these are all in a line. These pins are all connected. So we need to hook the resistor into this sort of channel over here. And yeah, we're going to use that as ground. Okay, so that makes sense to me. So the resistors also came on a little sort of, I think it's tape on the end of them. So we'll put that over there. So what we need is the resistors to go from the left leg of each LED. So like this. I don't think it actually matters which row we put them in. So we'll do that into the blue channel, which for me is here. My breadboard's the opposite. My breadboard's upside down versus their diagram. But let me just pick this up and put it in there. Right, so there's one. So now what we need to do is replicate that for the other two. Put the resistors in. So there's a second one, and let's do that. And we have two. And a third one coming up. So there are things you can get that pre-bend these resistor legs so that they're sort of the right gap, if you like, between things. I think those are quite handy, but I don't have one. So we'll just do this. Sometimes I just wrap them around like a pencil or something that approximates the right size. Okay, so just tidying a little bit. Make sure everything's reasonably well connected. Hey, there we go. Let's just make that big a second so we can see what has happened here. Again, I need to set up the Stream Deck so I can do this by key presses. So there we go. We've now got not the greatest or straightest bit of wiring, but you get the idea. The resistor left legs and the lower blue channels are connected as they have asked us to do. So back to here. Right, now grab the jumper wires. So, okay, we got these. These are color coded, so we can use the colors, I guess. You need one wire connecting the blue channel to a ground pin on your Pico. We suggest using physical pin 38. The Picos have quite a number of ground pins, so we could use any of them because they're all the same, but let's go with this. 38, and we'll need to use the pin out and connect the right leg of each LED to a GPIO pin. So here's the ground, the black thing down here. So we are going to connect the blue rail. We'll use the black wire. So we're going to connect the blue rail. It doesn't really matter where we do it, to pin 38 on the Pico. So there's the ground in the blue rail. Let's see where 38 is on the Pico. So it's up here. So this is the USB end of it. 40 VBus, 39 VSys, 38 ground. So it's the third one down. So let's third one down, and let's change the fuel. So I've got a 1, 2, 3, 2, 3. Put that there. That's for good measure. At least line it up. It doesn't have to. So there's my ground. connecting everything on that row. So that pin on the Pico to the blue, and then the blue at the other end here has the resistors on it, and then the resistors jump across to one leg of the LEDs. So that's part of the circuit. That's the ground. So what we need to do now is add, I would imagine, connections to the GPIOs so we can control these. So the way that's going to work is we're going to turn on and off power, and it will complete the circuit for each different LED. So we need here, and we're going to have to follow their wiring guide, because I'm guessing the code will line up with this, and the code will need to know these numbers. We need GPIO 18, 19, and 20. So physical pins 24, 25, and 26. And we're going to assume that red is the closest to the Pico, but we don't know that yet because they're all really clear. They're not colors. It doesn't matter what color jumper wires you use, but we'll actually use, we've been given a red, yellow, and a white. So we'll use red for red and yellow for yellow and so on. So, okay. So we need red goes to, where are we? Physical pin 24. So physical pin 24 is on this same side. It's the fourth up from the debug end of the Pi. So the debug end of the Pi is this end. So we've got 1, 2, 3, 4. That's row 14 on my thing. There, that's quite stiff. Right. So where do we put the other side of that then? And we put that in the other leg of the first LED, or in the same row. I'm just going to turn it around to do this a bit better. This is where this gets a bit messy. So we're going to put that in where the LED's other leg is. So hopefully what you can see here, and let's make that a bit bigger, is that LED there now has one of its legs has a resistor, the other leg has the essentially what's the power cable. I'm going to replicate this for all three of them. So the next one goes to the next one along. So next one along closer to, sorry, away from the debug header. So that one, and that needs to land in yuck. Really do some better light here as well. That lands there, I would hope. And then finally, let's do this one, which goes, of course, it's furthest away, isn't it? This one goes here and should land here next to that. Okay, so we've now got a slightly messy circuit, but hopefully we've got 3 LEDs and we've got all the wiring that we need, and hopefully that's done correctly. Well, it's time to find out. So probably time to write some code. So everything's hooked up. Let's code some Blinky and hope we don't blow anything up because don't have any spare parts. So activity 1, light each LED. So we'll use some of the code we learned yesterday, which I actually threw away. So never mind. So what we'll need to do, oh yeah, never assumed you turned your computer off after yesterday's box. That's a good, sensible assumption to make. So we're going to jump back into Thonny and we're going to hook up our device. So I've got Thonny here. Let's just do new. said I've got funny here somewhere. Okay, let's quit funny and restart him. There we go. Right. So I've got funny here, as we had yesterday. I will connect this Pico here to this USB thing, and that powers up the Pico and hopefully doesn't immediately destroy any LEDs. So, right, that should be powered now. We should be able to get a MicroPython prompt by hitting this stop thing. Yeah, there we go. So we've got MicroPython 1, 2, 1. So remember, there's two ways we can do code here. We can write code up here and send it all to the device, or this is a Python REPL. We can essentially run code immediately here. So let's see what they want us to do. A time module. So we did use this a little bit yesterday when I did blinking the internal LED. So we're going to use that again today. And we're going to use the pin module that we used before. And okay, so here's the code, copy into Bonnie and then run in the usual way by hitting the green button. So we're going to do the prepare some code and run it. Once you've lit each LED and you know which color it is, rearrange them to get the correct order. So yeah, it's a bit of a lottery of, it's a bit like playing Wordle or something. Let's see how many we get right at the first go. But first, let's look at our code. So we're importing the pin thing, which is the abstraction for the GPIO. We are importing time, which is pretty familiar Python thing. And then we're going to have variables for each pin. We're going to say the red one is the one that's hooked up to logical pin 18, amber 19, green 20, and hopefully those are right, but we'll swap things around if necessary. And then this is going to turn them all on. We're going to sleep for 5 seconds and turn them off again. So this should help us to find out what is going on. So I've got a very big font size on purpose in here, which means we can pull this shell down a little bit because we want some. All right, so there's our code. So what we're going to do is run that, hope that, let's try and get this into some sort of decent viewing angle from the camera. Yellow wire's in the way it wants to go that way. And see what happens. Will we have magic smoke? Will we have lights? Are they in the right order? Oh, we got lights. So we've got red. This is actually hard to see on the camera. Let's run it again. They're so bright, but what we've got is red, green, yellow. So first off, the circuit works. That's good. And what we need to do is just, I'll run this on the big display. So hopefully you can see it a bit better. So these are going to come on. This wire is annoyingly in the way, but so you can kind of see that one's red, and you can kind of see the other two are very bright. The other thing with LEDs is they normally need diffusing for this very reason. So careful not to look your LEDs straight in the eye. So this one's coming out of here. And let's put it to one side. This one is going into, all right, where did you have that? There, I think. And then this one can go back to like that. You're wondering why this is a bit of a struggle for me. I smashed up my hand some years ago, and it doesn't always do what it's told. So right, I should have disconnected the power anyway. I'm just going to disconnect the power and do this where I can handle it a bit more easily with my damaged hand. These legs have got a little bit close. I'm just spreading them out. So we're making a little bit of a meal of this, but right, that's in place. That's in place, and that's in place. Right. So hopefully, what we've got when we do this now, I've adjusted them, is we connect Thonny back up, and when I'm going to hit the play button in Thonny, yeah, we've now got red, yellow, green, and there you go. You can actually sort of see that red, yellow, and green. There we go. So they're in the right order. We've put 3 LEDs on there, so that's good. So let's see if there's anything else they want us to do with this today. There probably will be. So activity 2. So activity 1 complete. Activity 2, flashing the LEDs. So let's make things a little bit more interesting by making our LEDs flash. And we're going to have a while loop. This is starting to look like my articles on my website for traffic lights, where I looked at doing the traffic light pattern of a while true loop with some sleeps in. So you do red, red, amber if you're in Britain, and then green, or just red, green if you're in the US, then amber, then red. So let's see. We also need to introduce variables, indentation, and code commentary. Okay. So while loops will repeat the block of code as long as the condition remains true. Indeed. So if we wanted to count how many bounces we've done, we need a variable to do that, for example. So we're going to make the LEDs flash 10 times. And it says we're also going to start putting comments in. That's a good idea if you want to remember what something does, or if it's not obvious to other people. So, yep, comments in Python begin with the hash, or if you're an American pound character, and run to the end of the line. So that's okay. Variable is container for storing values. Yep. And indentation. This is a Python thing. So the way that we do loops in Python is it runs the statements that are indented or pushed over to the right down to the bottom of that block statements, and then repeats. Other languages use things like curly braces for what's called block scoping. So Python uses indenting. So okay, let's just copy this into Funny and then like do a quick analysis of what it's doing. Right. So again, we're importing the pin that we need and the time. We've got our LEDs set up like we used to have. I'm going to put a space there so it's at least consistent. That doesn't actually matter. Okay, so we're having a counter variable that starts at 1, and then we're saying, well, counter is less than 11, so that's going to go 10 times because it's less than 11, assuming we're going to add 1 to counter somewhere in this loop. I'm going to print out the counter. That will appear down here in the bottom on the console. We're going to turn all the LEDs on by setting their value to 1, sleep for half a second, turn them off, sleep for half a second, add 1 to the counter, and then that's the end here, right? So if these statements weren't indented, this program would stop running. Because they're indented and they're in this while loop, it's going to run until this condition is true. So it's going to run like 10 times. So let us run the code here, and you'll see the lights are flashing, and you'll see there's a number appearing down the bottom, which is the value of the counter. So that's eventually going to stop. So 10, and there we go, off, stopped. So that works. So we've got a loop now, and we're doing something a little bit like what I did with the internal LED yesterday when we had a sort of off piece to play with things. Oops. Come back here. Try changing both of the time sleep values to different numbers. It'll change the speeds. Yeah, so it will. So if we change this to like 1, we'll wait a second, and so on. And you can also change the while loop to run forever. So the way we do that is while loops run until their condition is not true. So one way we can make something run forever is just give it a condition that's always going to be true. So literally Boolean true is always going to be true. So we can do that. But now what we're going to do is make the LEDs flash one after the other. So a bit like traffic lights. So there are more advanced ways of doing this. So yeah, we could store the LED states somewhere else, and it looks like we're going to do something with lists in the future, so we won't go there today. So let's do, again, let's copy this and look at it in Thonny. So, right. what do we got now? We've got the same preamble, LEDs and the counter. We're still going to do less than 11. We are printing out the current counter. So we're doing basically the UK traffic light sequence, or are we? No, we're not. So we're doing something slightly like it. So we're doing red on and turn everything else off. And then for the UK traffic lights, it will be red amber. But here we're doing red off and just amber, the yellow one on, and then green on. And then we're adding one to the counter. So what we can expect to happen is, let's do it. It's going to cycle through the LEDs like so. So that's kind of like Christmassy. It is an advent calendar after all. Let's look at this on the. There you go. So it's cycling through the LEDs. And if we wanted traffic lights, we could just change this so that this had a few more blocks of code. So we do red and then amber, green, and then amber and then red, and we might change the delays so that the red amber state is fairly short in the traffic light, and then the green one is a bit longer, and so on. And that's exactly what. Let's go look at this. That's exactly what I built ages ago for the Raspberry Pi. So let's do for the light regular Raspberry Pi. So there's all of these traffic light articles on my website, and one of them is the original. Let's see, somewhere in here. Well, I'll tell you what I can do. I could pick any one of these. Let's pick the Java one. And then they all have a list of the other ones. So, okay. So here's the original Python one. And life would be good if you shared your desktop. There we go. So here's the original Python article from my website where I built these traffic lights. And what we'll see is this is regular Python because it's a normal Raspberry Pi, not MicroPython, but things are pretty similar. So here's our code for that, and it loops forever, and it does, well, let's see. So regular Python to the right, MicroPython to the left. Different pin numbers because I had it set up differently, but yeah, similar things. We're basically saying set a pin to true rather than set the value to 1. It does the same thing. We do a sleep in red, and then we turn amber on as well, which was the next one, and green by turning red and amber to false, and so on. And then you've got traffic lights. So once you've sort of grasped these concepts, you can do a few things, but also this stuff applies to regular Python, normal Raspberry Pi as well. So let's just reset the zoom level on there and come back to here. So yeah, we've now got flashy lights, and let's run it again. Flashy lights. And we are complete for day 2. So that took probably longer than if you were going to do it yourself, because I was talking through it and I have not great hands. So I'm not particularly good at putting things into breadboards. But so what did we learn today? We created a circuit. We did. We've got all of these wires on the breadboard with the Pico. And these are great for prototyping things, but this is not how you build like an actual product. If you wanted to ship this to someone, you probably want the LEDs in a box, and then you probably solder all the wires. But while you're playing with something and getting it working, or it's a temporary thing that you're going to disassemble and reuse the components, the breadboards are great because they're no soldering. You just push things in. We're not getting the soldering iron out and soldering up that circuit. And here's something important. Always read through to the end. Please do not disassemble the circuit, as we will be using it again with the contents in the next box. See you all tomorrow. So I will not disassemble it. I'll leave it on the desk. Let's power it down. And I will leave this thing that we built here, that we can see here. I will leave that exactly as it is now. And I mean, yeah, come back to do box 3. So when are we going to do box 3 is probably a good question to answer at this point. I've said this isn't necessarily a daily live stream thing. I do have some semblance of other things that I have to get done periodically. But tomorrow, I am hoping to schedule something in the afternoon UK time, maybe the early afternoon, as I've got something in the morning that I need to go to that hopefully I can talk about when I've been there because it's totally not to do with tech or work, but it's something I'm interested in and quite exciting and not something you normally get the chance to do. So hopefully we can talk about that tomorrow, and I will aim to figure out a time and put something out on the socials and so forth later on today. So if you want to see when tomorrow's stream is, follow me on Twitter, or if you're watching this on YouTube, just subscribe or whatever, and you'll get a notification. Um, in the meantime, I'm still gently promoting the. If you find any of this stuff useful or fun, or you want to help fund some of it, then I've got a Ko-fi, so have fun with that. And if you just want to see all the projects, they're on my website and they're all free and everything's MIT licensed. So you can have fun with all of the projects that I've done with your own hardware. Anyways, I'm going to go and get some more coffee. It's now, I don't know, middle of the morning in the UK. Got somebody coming to do a job on the house later, which is why this was a morning stream, because we didn't want somebody like banging around and making noise and needing my attention in the background. So I will see you tomorrow, and I will try and publish when that is as soon as possible. All right. Take care, everybody. Bye.